Hello and welcome. In this video, we are going to demonstrate a running light effect and RGB LED control on Numato Mimas A7 Mini FPGA board. So we will write a Verilog module which will control an 8-bit LED arrays and an RGB LED using the input clock, a reset signal and 3 switches. We will use the Numato Mimas A7 Mini FPGA board. So first we will divide the input clock to generate a slower clock which is used to control the LEDs, because the input clock on the FPGA board is really very fast. So we will first generate a slower clock. The LEDs will continuously shift in a running light effect which will create a moving pattern across the 8 LEDs. The RGB LED will cycle through the red, green and blue color. This will happen in the initial state. Then we will also use the switches to control the specific state of the LEDs and the RGB LED. That will allow us for manual control to display different patterns. So let us jump into the Vivado project. So as you can see, this is the project summary. This is the project name. This is the project location. This FPGA board uses RTX 7 FPGA chip. So you can see I am using this FPGA board. So this is the actual, this is the photo of the FPGA board. We will also jump into the actual hardware after some time. So as you can see, this button will be used as a reset switch. This button will be used as switch 0. This button will be used as switch 0, switch 1, and this button will be used as switch 2. So this is reset, this is switch 0, this is switch 1, this is switch 2. So we have 4 buttons that are used as reset buttons and switches. Then you can also see we have 8 LEDs here, and this is the RGB LED. So this is the basic layout of the FPGA board. Now let us see the Verilog code. So as you can see, I have written a Verilog code. So the clock is the input, it is the clock of the FPGA board. Then this is the reset signal. So the reset signal is used to initialize or reset the operation. The push button switch is used as the reset button. The topmost push button switch is used as the reset button. Then we have 3 switches. The other 3 push buttons are used as 3 switches. So the inputs from these switches will be used to control the LEDs and the RGB LED. Then we have the 8 LEDs as the output and also the RGB LED. So it is a 3-bit output for RGB LED because it has 3 different colors. It can display 3 different colors: red, green and blue. So this is the initial condition. This is the initial condition. So in this loop, we are generating a slower clock for the visible display. Otherwise, it will be too fast for our eyes to see. So we are using a always block. So if reset equal to 1, we are setting the count register to 0. And this clock L is the slower clock. If the count goes to this value, so this is a very large value, so it will divide the very fast clock to become a very slower clock. So this clock is a slower clock. So by this, so in these lines we are generating a slower clock for the visible display. Then the main control of the LEDs and the RGB LED happens through this always block. So we are using 2 always block. So this always block is controlled on the positive edge of the clock and positive edge of the reset button. So if reset button is equal to 1, then the LEDs out will be in this initial state and this RGB LED will be in the initial state. Otherwise, if the reset button is not high, Then a running light effect is created by shifting the LEDs. So you can see in this line, the shifting effect of the LEDs is happening. So we are shifting the values of the LEDs. Also the RGB LED is shifting and it will be cycling through different colors, which are the red, green and the blue. But if switch 0 is pressed, then it will turn all the LEDs on except the last one, and it will set the RGB LED to red. So you can see all the LEDs are on except the last one, and the RGB LED is set to red color. If switch 1 is pressed, it will turn all the LEDs except the second to the last one on and set the RGB LED to green. So only the second to the last LED will be off, all other LEDs will be on. And if switch 2 is pressed, then all the LEDs will be on except the third to the last one. So you can see only the third to the last value is 0, and the RGB LED will be set to blue color. So this is the simple Verilog code. So now we will see the constraint file. So the constraint file is the .xdc file. So you can see we have these 8 pins and we have assigned them to LED 0, LED 1, LED 2, LED 3, LED 4, LED 5, LED 6 and LED 7. Then we have these 3 push buttons. So these 3 push buttons are assigned to switch 0, switch 1 and switch 2. And finally, we have the RGB LED. So that is also assigned RGB 0, RGB 1 and RGB 2. On the top, we can see we have this clock. So it is assigned to our clock input, and this push button N6 is assigned to our reset input. So this is the constraint file that we have made for mapping of our signals to the FPGA hardware. The onboard clock is 100 megahertz clock. So now after this constraint file is written, we will run the synthesis part, we will run the implementation part, we will generate the bit stream file, we will open the hardware manager and connect the FPGA board. And now let us jump into the FPGA board and let us see the outputs for ourselves and verify that our code is working or not. So this is the implementation of running light effect on LEDs, and we are controlling the RGB LED. So this is the RGB LED. These are 4 switches. So this is reset button, this is switch 0, this is switch 1, this is switch 2. So when I press the reset button, then only the lowest LED glows and the RGB LED shows RGB color. When I press the switch 0, then only the lowest LED is off, all other LEDs are on, and the RGB LEDs is showing red color. Then when I press the switch 1, then the LED 1 is off, all other LEDs are on, and the RGB LED is showing green color. And when I press the last switch, then LED 2 is off and the RGB LED is showing the blue color. So in this way we are demonstrating a running light effect on LEDs and controlling the RGB LED. So now I have turned the light off, and this will better demonstrate this project. So it is showing RGB color Now it is showing red color, now it is showing green color, and now it is showing blue color. Thank you.